Hello, this is Britt Caswell with another video on graphing quadratics. In this video, we're going to focus on graphing quadratics in vertex form. So you might wonder what vertex form looks like. It usually looks like either y or f of x is equal to a times x minus h squared plus k. So there's some kind of cool key features here. This a value tells us how far up or down the parabola moves when you move one unit to the side from the vertex. And then this h and k is actually telling us what our vertex is for our parabola. Now you want to keep a lookout because in our equation it says x minus h. So when you actually go to write a number in here, it often looks like you're swapping the signs out back and forth, which you'll see here on our example. So when we go to graph in vertex form, we usually want 5 points. One of the main ones I just mentioned here is the vertex. That vertex lies on what is called the axis of symmetry, which is this dotted line that you see going through our parabola here. The axis of symmetry is where the parabola kind of mirrors itself. It makes a perfect U shape. So when I go to graph, what I do is actually look for what I call the usual suspects. Usually I start by finding what are called the zeros. Okay, the zeros are these bad boys right here, where the parabola is crossing the x-axis. In mathematics, we like to name these many times. They can also be called solutions. They can also be called x-intercepts. We just go wild with the names there. So to find the zeros, all that we do is we set the equation equal to 0 and solve. This part here, it tends to be the longest part, finding those zeros. The next usual suspect I have is the axis of symmetry / the vertex. Now in other forms, the axis of symmetry is usually more difficult to find than everything else, but in vertex form, the axis of symmetry and vertex just kind of pop out of the problem at you, which is really nice. So for the axis of symmetry, it occurs at x equals h. So whatever number is being subtracted from x here is what your axis of symmetry is. To find your vertex, again, it's at hk. So it's just that ordered pair there. The last of our usual suspects is the Y-intercept. So to find the Y-intercept, all that you do is you plug in a 0 for x, and then you would solve. Now if you notice, we've only talked about 4 points. To find the 5th point, what I usually tend to do is I tend to reflect this Y-intercept across the axis of symmetry. So that would get me another one. Let's see, 1, 2, 3, 4. 1, 2, 3. Oh, I need another line. 4. That would be like right there-ish. So you tend to want to reflect it across the axis of symmetry in order to get a 5th point. I usually call that the reflection point or just the reflection. So let's go ahead and let's look at an example. So here we are, we have something in vertex form. So let's start with our zeros. I tend to go through and actually find the values for each of our points before I graph it. So you'll see I have kind of like a checklist on the left-hand side of the screen. And then once I have all of my checklist, I go through and I graph it. So to find the zeros, again, you take this equation, and where the y is, you put a 0. So I'm setting the equation equal to 0. All right, and then now we go about solving it. So the first thing that we have to do to get x alone is get rid of any addition and subtraction from the grouping symbol. So I'm going to add 28 to each side. So what we're trying to do essentially to solve is we are trying to get this set of grouping symbols that's being squared by itself. So I have to get rid of anything added or subtracted and multiplied or divided from it. So that gives me 4 equals x minus 1 squared. I'm just going to write that twice so that when I go to show my square root, you guys can see the extra step. So to undo a square, you need to take the square root. Now it's always very important when you go to solve these, if ever you take a square root to get rid of a square, you have to put a plus or minus in front of the constant. Otherwise, you'll cut off one of your answers. You'll only get 1, 0. So the square root of 4 is 2. So this side is plus or minus 2. Here, the square and the square root cancel out, leaving you with x minus 1. And then I'm going to add 1 to each side to isolate x. So right now my expression says 1 plus or minus 2 is equal to x. Now, this is something I can actually solve. These are numbers that can be combined. Most of the time with vertex form, this will be some kind of radical still that can't be simplified. I haven't shown you guys how to do that yet. That'll be on a future video. But a lot of times you'll end up stopping at this step right here. Oops. So that plus or minus is saying that there's 2 answers. One where it's a plus, and one where it's a minus. So if you create the 2 equations, they look exactly the same, except we split that sign up. So my 2 possible values for x are 3 and negative 1. So those are my 2 zeros. The next thing I usually look for is the axis of symmetry. Again, that axis of symmetry is just at x equals and then whatever number is being subtracted from x here. So this says x minus 1, so it's x equals 1. Now, if in an alternate timeline you had x plus 1 here, then this would be a negative 1. So the sign just looks like it flops. Then the vertex, remember the vertex lies on the axis of symmetry, so that 1 always just kind of falls down. The other value here is your k value, so there's a minus 28 here at the end. That's where my vertex will lie. The next thing I look for is the Y-intercept. To find the Y-intercept, remember that x is equal to 0 anywhere on that y-axis. So to calculate the y-intercept, I'm going to take my equation, and where the x is, I'm going to replace it with a 0. The rest of this is just arithmetic. So we solve what's in our parentheses. 0 minus 1 is negative 1. Now, negative 1 squared is just 1. 7 times 1 is 7. And 7 minus 28 is negative 21. So my y-intercept is at negative 21. And then to get my reflection point, the reflection point will be at the same y value, the same negative 21, but the x value changes. All that I do is I take the value of x at my vertex or axis of symmetry and I multiply it by 2. So 1 times 2 is 2, and that gets me my reflection point. So now we are all set to graph. A lot of times what I tend to do on my graphs is I tend to put tick marks on the x-axis, but because our y-axis has such large numbers, I tend to not tick mark that. I just kind of label where it is on the axis. All right, so my zeros, I have 1 at 3. Notice that whenever you put a point, you label what that point is. You mark that ordered pair. That is so that people viewing your problem can actually tell what's happening a lot quicker and easier. Okay, math is about communication, and if you aren't communicating very clearly, it can be very frustrating for other people to read your work. So my axis of symmetry is at x equals 1, so there's my vertical line, at x equals 1. Now my vertex is on here, but it's all the way down at negative 28. So what I'm going to do is I'm just going to call this part right here negative 28. And then I'm going to draw my vertex and label my vertex. That way it's very clear even though I don't have tick marks on my bar. Then my y-intercept is at 0, negative 21. It's about right here. There it is labeled. Now my reflection is at 2, negative 21. So here's 2. It's at about the same level. And you see with these 5 points that you have a very nice U. If one of these points is not quite where it should be, then you want to start checking your work for errors, making sure that your values are correct. And there's our nice parabola. Now remember that parabolas tend to go on for forever, so you need to make sure to have arrows on the endpoints. And that'll do it. Until next time.